Now let's look at what are called the box-Cox transformation, where we take the y value and take a root of square root or cube root, so that dampens out the trend that may be present. So first the transformation, so let's look at the square root transformation, where we can use the square root function in Excel, okay, square root of the actual value, and that's the transformation. Okay, copy that. Then we have the transformation now. We've done the transformation. Okay, put the border back here and back there. Okay, now we set up the initial values using that, and we can use the initial value formula way back from here, and these are the formulas that we can copy. And of course, remember, the smoothing formulas in these two cells must be adjusted for the proper alpha and beta cells. So let's copy these formulas down here, and when we copy, we must always make sure that the formulas are correct. So this is correct, this is average, and G91, that's correct. So that is correct. Now here we take, okay, here is the problem. So instead of, so here the errors are kind of, okay, so we need to find the error first, so which will be that minus that. Okay, then we must have H92, and that is wrong. It's not H92, it is F91. So this should be F91 plus the alpha value must come from here, and we have to enter a trial value there, which we will do in just a second. So F91 times C85 and then I92. So that's good. So let's say we use 0.2 and 0.3. Now trend would be G91 plus, this should be C86, okay, plus F92 minus H92, L minus F. Okay, so that's good. So now we can copy these. Put the border back. Okay. Now we need to transform. So we've set the model up. Now we need to transform the forecast for the transformed y back into forecast for y. And we'll do that starting from period 5. So the antidote for square root transformation is to square it. To take that value and square it. And that will bring it back to our original value. And here we need to reduce the number of decimal places, and all those problem pound signs will go away. And then we set up the error measures. Okay, and the error measures, okay, are starting from period 5 through 16. Okay, and these three measures. Then MASE will be, okay, similar. That are the first two ranges. The random walk is starting from this cell up to that, and same here for Thiel's U. And now we can run solver. Yeah, once again we have to reset this to start with a clean slate. And now this is the square root transformation. So we want to minimize the RMSE of square root transformation, and these two, alpha and beta. Okay, add alpha and beta to be less than or equal to 1. and then we solve. Okay, click OK. So here are the optimum values for alpha and beta. Now, of course, remember we are using the LES model here for the square root transformation. Okay, I'm only illustrating what's given in the textbook. For each of them, you may want to try different. In a real life situation, for each transformation, you have to try different models and minimizing, using solver with the RMSE ones and MAPE ones and so on. So to keep it brief, I'm not going over all of that because you've already seen those previously. So here I'm only looking at one measure and one model. Okay, now let's look at cube root model.